Welcome to Lesson 3A in our Math 0232 course. In the next preview assignment and in the next class, you'll need to be able to use percentages and percentage equations to work with data sets. A quick reminder, go print the worksheet for this Lesson 3A. Work along with me. Several times I'll ask you to do work before we get to it on this video. And let's start by reading the term percent. It means per 100. And it's another way of representing a fraction with a denominator of 100. Percentages are always expressed with a percentage sign, the symbol as you see there. Percentages can consist of numbers between 0 and 100, but it's also possible to have a percentage greater than 100. That's especially nice if you've invested money. Percentages may also involve decimal values. Go ahead, hit pause. You complete question number 1 and come back when you're finished. So on question 1, I hope you're still using good skills of underlining, highlighting, touching. In other words, right here, it says, according to the 2017 data from the FFFAA, about 7% of all pilots are female. Couple of thoughts here. All, 7% of pilots are female. This means that out of 100 pilots, 7 are female. We can convert this percentage to a fraction or to a decimal. First thing says write 7 as a fraction. I would go back up here to where it says percent means per 100. So instead of saying 7%, I'm going to say 7 per, put a vinculum, per 100. We then need to practice our reducing or simplifying to make this a smaller fraction, reduced fraction, but with 7 being a prime number, we're there. The next part is asking us to write 7 as a decimal. 7%, when you divide this in your calculator, will be 0.07. So the per 100 plays in well, and this is something you need to be solid on. If you still feel a little shaky on the fractions or decimals, you need to look for a resource in the back of the 1332 book or Google more information, search the internet for more information, but don't leave this question number 1 without feeling comfortable of how to convert from fractions to decimals, and we'll do more with decimals to fractions. So now that you're feeling more comfortable with fractions, decimals, percentages, question number 2 asks us to complete the chart. You need to complete the chart first before watching the video, and then come back and we'll complete the chart or double check the chart and your numbers and my numbers when you get back. So make sure you go ahead and do question number 2 by yourself. I would like to start at 120%, and it is 120%, and we do need to reduce. There are many ways to reduce. You can take a while to reduce, like divide by 2 a whole bunch, or you can go for a large number. You could say that I'm going to factor out 20. I'm going to go off on the side here that if I have 120 divided by 100, I could write that as 20 times 6 and 20 times 5. This value becomes 1, and that leaves us 6/5 as our fraction. As a decimal, we'll take our 120% and divide 120 by 100, and we'll get that it's 1 2/10. Now they're giving us a fraction and asking us to go either way. So I'm going to start with the 5/4. When we divide 4 into 5, we get 1 and 1/4. They're asking for a percentage and they're asking for a decimal. When you divided this, if you divide it on a calculator, it may have come out like this, 1 25/100. Yay, that's our decimal. And then to go to a percentage from a decimal, we will take our 1.25 or 1 25/100, and this time, whereas to go from fraction to decimal, we divided by fraction. To go from decimal to, to where I don't have it on here. Well, that was to go to decimal. The last problem we did, if you're going from a decimal to a percentage, we've got to multiply by 100 and then include the symbol. And earlier we went from a percentage to a decimal, and that's where we divided by 100. There is a cheesy little trick. It is better for you to know the 100 and 100, but here's a cheesy trick. If you are in decimal for D for decimal and you want to go 2%, you're going to move your decimal 2 places to the right. In a decimal, right here's a decimal, we're going to move our decimal 2 places to the right and it becomes 125. If you are in a percent and want to go to a decimal, a cheesy way to remember this is if you're in a percent, to go to a decimal, you'll go to the left 2 decimal spaces. So we would go to the left 2 decimal spaces. That would put us at 1.25. And that is, again, for the third time, a cheesy way to do this. It is better to remember when you divide by 100 or multiply by 100. Speaking of, here is a decimal. We need to go to a percent. To go to a percent, we will take our decimal, multiply it times 100. That puts us at 45 6/10%. And then we have decimal to a fraction. We can use either one of these to get there. I'll go ahead and start with 456 100ths. Oh, sorry, 1,000ths. And then from there, we need to reduce. It may take us a little bit to reduce, and I'm not sure how much room I've got here. Let me see. 456. I'd like to go ahead, 2 would work, but I'd like to go ahead and try a 4. So you can grab a calculator, and on your calculator, I'm going to take 456 and divide it by 4. And so I'm getting 114 times 4 is our numerator, and our denominator is 250 times 4. Those become 1, and we're left with the fraction of 114 250ths. I'm not content that that might not go further. Oh my gosh, they're even. They'll definitely go further. We can at least divide by 2. Let me go ahead and rewrite that for no reason. 114 divided by 2. We have 2 times 57 for the numerator and 2 times 125 for the denominator. I think we're there. So the fraction equivalent is 57 125ths. Let's finish up on our chart. We have percentage to decimal. From percentage to fraction, we're going to have 1 6/10 per 100. We have a decimal to deal with, and one way to do that is if I multiply by 10, I have to multiply by 10 here, and I get 16 over 1,000. I'm going to go ahead and take out a 4. In other words, 4 times 4 over. Yep, there's no room to write there. Let me go write that up in the corner, that if I have 16 1,000, this, if I try to take out a 4, I get 4 times 4 and 4 times 250. Well, that's great, but 4 times 250, those have a 2 in them at least. That becomes 1, and I get 2 over 125. Finally, we're going to take our percentage, go to a decimal. We need to multiply it by 100, and we get 160%. Oh, y'all, I'm so sorry. That is hideous. We are at a percent. We're going to decimal. I guess I need to use my cheesy way. For percent, and we're going to decimal, I need to go 2 spaces to the left. Better, I should say, it's 1.6 divided by 100. And when we divide it out, we're going to get 0.016 or 16 thousandths. I've asked you to start a glossary page or some kind of electronic document or sticky notes, but something where you're going to remember things you need to memorize. You need to know what they are, when to use them, and what they look like. So this is one you need to memorize. It's a percentage equation. It says to solve problems involving percentages, we're going to use this formula. I need you to notice that the part is on the far left, or if you flip it around, it could be on the right, but the part equals a percentage times the base. So remember, part equals percentage times base. I need you to go ahead and hit pause. I need you to try, do, complete questions 3 and 4 before watching the video. So take time to invest in completing questions 3 and 4, hit pause, and then I'll be waiting to work on questions 3 on the video. So problems involving percentages involve first determining what is known and what is unknown. What do we know? What do we need to know? We then solve the equation for what we don't know. In using the formula, the percentage gets converted to a decimal value. I want to put that in red. The percentage gets converted to a decimal value. So now that you've memorized the formula, part equals percentage times base or whole, you need to also remember when using that formula, you must convert the percentage to a decimal every time. The base is the whole. It's the quantity defined in the problem, or it's the whole quantity. So on number 3, according to the FAA, there were 149,121 flight pilot students, 19,219 of whom were female. What is the base, the whole, the large, well, I can't say larger amount, but what is the whole component in this problem? It's going to be our 149,121 pilot students, the whole class. What is the part that we're talking about? Well, part of that class were female. What percentage of flight pilot students were female? Show your work and round to the nearest hundredth of a percent. So we have a job to do and we have directions before we say we are totally done. At the very top, it said find out what you know and what you don't know. So looking at our problem, they want to know what percentage of flight pilot students are or were female. Show your work and round to the nearest 100th of a percent. So the formula earlier, and I'm a firm believer that you always write the formula down first, part equals part, the percentage times the base. So let's fill in what we know. The part would be the women. There are 19,219 women. We don't know the percentage, but we do know the base. They're asking us what percentage. So we'll go ahead and call this X, and we'll solve for the unknown. We'll solve for X by dividing both sides by the whole. Grab a calculator. We've already been practicing how to properly get this in our calculators. And when we divide, we get this number for X. They're asking us to round it to the nearest 100th of a percent. This is currently in a decimal form, so we need to multiply it by 100, and we're going to get 12 point or 12 and if we're going to the hundredths, the decimal is now here, tenths, hundredths, and we need to look one behind, and we'll be rounding to 12 and 89 hundredths of a percent are women out of this entire class. Again, make sure you've already attempted question 4. You've given it your best shot, even looked for some electronic or internet resources to help you. And now let's go through it together, making notes of what you remembered, what worked for you, what didn't, and then what you'll need to remember for an upcoming quiz. The I do it every time, FAA reported that 9,971 women were private pilots in 2017, or this amount represented 6 and 1400% of the total, the whole number of pilots. What values are given? We know 9,971 women are part of this whole event. We know the percentage that they represent, is 6 and 1400%. And what we don't know is what were the total number of private pilots. Part B, so how many private pilots were there? Show your work and round to the nearest whole number. Firmly believe you should write down the formula first, where part equals the percentage times the base or the whole. We know the part, it's the women, and we know the percentage, and you remembered to convert it to a decimal, but we don't know the base, the total number of pilots, private pilots. So let's divide both sides by our 614 10,000ths. Grab a calculator. This will become 1. Punch it in carefully and correctly. And then it asks us to round to the nearest whole number. The whole or base number I see on my calculator is 162,394.137. So if I'm rounding to the nearest whole number, I look at the 10th, and my 162,394 will stay as it is, and these are the total number of private pilots, of the which 6 and 1400% were women. The final part of our worksheet is question number 5, talking about populations and samples. You need to pause the video, go work on question 5, parts A, B, C, D, and E, and then come back. Now that you're back, the part in the definition about population and sample, let's see if I have it here. I don't have it on this one, but on your worksheet, it's talking about a population consists of all subjects being studied. Wow, that sounds just like the whole or the base. And a sample is a group of subjects selected from the population, so they're a part of the whole population, and it says on there the population is the base or the whole. The question says, a polling company is interested in determining how many voters in a city favor a particular candidate. It says that there are 208,655 voters in the city. So underline that on your page. And then it says the company surveyed 2,500 of these voters. So this is our survey. Then there is a result that out of the survey, 200 out of this, 200 people said that they favored candidate A. So from the whole, we have a part, and from this sample, we have some results. So part A is how many people are in the population and how many are in the sample. Population, 208,655 voters. The sample, 2,500 voters are selected for this sample. Part B, make sure you've already done these and you're just reading along and correcting, checking. And if and when you all see or hear mistakes in my videos, please email me. I need to get those corrected because nothing is ever intentional. It's going to be purely a mistake, not on purpose. Part B, what percentage of the population, what percentage of the whole population, maybe throw in a few extra words there, whole population is in the sample. Round the percentage to the nearest 10th. Got to follow those directions all the way through. So our sample is a part. We don't know the percentage, but we do know the entire population. We need to follow the same processes we've been following to solve our one-step equation. We need to remember about the decimal and when we get a decimal, that we need to convert it to a percentage. This becomes 1. Grabbing your calculator, we have 2,500 divided by 208,655. It's in a decimal form, So I'm going to multiply it by 100, and I get on my calculator screen 1 and 198,150. The directions ask us to round this to the nearest tenth, meaning here is my tenth, that's the place to the right of it. My final answer will be about 1 2/10%. Moving on to part C, what percentage of the sample? Ooh, percent sample favored candidate A. And whoa, is this the same? And why or why not? Let's back up and do this percentage. So now the sample was the part, but now the sample is going to be the whole. Because the question is, what percentage of the whole is our sample who favored candidate A? So we will set this up, and I haven't rewritten the formula once on here, and I just told you that that was important. It's important to write the sample, or to write the formula. Maybe it's because I don't have enough room. I don't know. I get 8/100ths for my decimal. When I multiply that times 100, I get 8%. It doesn't tell me where to round it. That one's nice and pretty. So we have 8% of the sample voted in favor for candidate A. Is this the same percentage of all the voters in the city? Why or why not? All of the voters in the city, well, all of the voters in the city are this 208,000. The sample is 2,500. One of the biggest things to always remember is what's the base? And when the base changes, our relationship changes. So is this the same percentage of all voters in the city? It's not the same of all voters in the city, since the sample is only one part of the total population. We finished this worksheet by completing parts D and E. Starting with part D, on election day, we have an amount of people who cast their vote. The question is, what percentage of the voters in the city actually voted? And round this percentage to the nearest hundredth. And so you have to play with it, reword it. You have to ask yourself, is 127 the part? Is it the whole? Well, I believe it's the part, because part of the voters, the eligible voters, voted. So the question is, what percentage of the eligible voters? Let me go back and find that number. The eligible voters, or the voters, are 208,655. So the question is asking, the people who actually did vote, what percentage of the entire voters is this? We're going to solve our equation. You're writing and grabbing a calculator, or just checking the answer that you already have. Grabbing a calculator, I'm going to take my 127,530 and divide it by 208,655. They are asking us to round to the nearest hundredth. So when I multiply by 100, I get 61.12003. If they want us to round to the nearest hundredth, I'm going to go to my hundredths place and look behind it. That 0 tells us we stay where we are, leave everything well enough alone, and we're getting about 61% of the voters did vote. And then a great question says, well, then how many votes did the poll predict that candidate A would receive? Because we looked at a sample. We found out something from the sample, and the sample said, well, 8%. The sample said our new part, the new part being those that would vote for candidate A according to our sample, said 8% of, 8% of the people who voted would vote for candidate A. So it is about, make sure you convert your 8% to a decimal. And I'm going to type in 0.08 times 127,530, and I get the number 202 and 4/10. But it asks us to, it doesn't tell us what to do. So since these are people we're talking about, let's call it 10,202, according to the sample, would have voted in favor for candidate A. This concludes our lesson, our Math 0232 Lesson 3A. Look at your calendar, see if you have more to do before our deadline.